Okay, for this, you have to use the two methods that I showed you, the difference of squares method, okay, and then the table method. All right, so you have to look at each question and figure out which one you have to use, the difference of squares or the table method. So you should know the difference of squares always has to have two terms and a subtraction sign between them, and you should be able to square whatever this is, like so, and square this term like so. So we'll look at that in a moment. So if you look at question A in the fake quiz, this is a table method. So what's common on the table? Well, each has an A, and at most it has an x squared. So you should put your brackets, and what's left on this table? Well, we took an A and two of these off, so we have an x, and we took both x squared and a off this table, so there's always left a 1. So there I factored it. Here you have three tables, so ask yourself what's common on all three tables, and you should realize that there's an x which is common on all three, so you have to take one off of there, you take one off of there, and when you take everything off that table there, there's always the hidden one there, like so. This one here, another table method. There's a common a on each table, and there's a common x. So if we look here, we take that, we take one of those, so we have x left. We take a and x off that table, so there's a 2 left, and there's a plus between them there. This again, we have two tables, and we can see there's something common on each table. First of all, each one has a -3. Okay, so I take a -3 off each table. So -15 is like saying -3 times 5. So I took one off here and one off here. And then each table has an x at least on the table. So what's left on this table when I take an x is one last x. And what's left on this table, well, we have the 5, but it becomes +5, right? Because we took the -3 off there, so now the +5 is left. And we took the x off, so we have this here. And then if you want to make sure that it's correct, if you factor in just to check, normally we don't factor in, but if you factor in, you should get back this original one. So you can always check your answer on the side to see if you did it right. So -3x times x is -3x squared. -3x times 5 is -15x. So on your scrap paper, you can check to see if you factored it right, actually, okay? This sort of looks like a difference of squares, but you always have to see if there's a table method here. And there is, because there's a common x on each table. So I take it off this table and one off this, and I'm left with 2x minus 7. All right. Another table method. They have one a I can take off, and one b I can take off. So there's still an a on that table and a b on this table. So I take one b, and what's left is a b from him. And then what's left on here is an a from him, and the plus sign is in between, okay? Now these are getting a little bit more tricky. It's still a table method, but now there's something common in the brackets, right? So you should see that there is a b plus 3 on both tables, and what's left on each table is an a here and a -5 there. So there we go. On this one here, it's a little bit more tricky because there's no brackets, but you can put brackets around here. You're allowed to do that because it doesn't change anything. So when you do that, you can now see that you have a table here and a table here. So we take the whole x plus 4 off each table, so that goes away and that goes away. And what's left on this table is x. And when we take everything off there, there's of course a hidden 1. So you have the plus sign here and the hidden 1 there, like so. So that was the page 1 of the fake quiz. So here we are. Take a look at this one. We have this table. So now we look at another table method, and there's x plus 2 squared and an x plus 2. So the common thing on each table is x plus 2. And what's left on this one when you take one of them off is still another x plus 2. And if you take this off, you have a -5. And now we can simplify the second bracket because you have 2 minus 5, and that's subtract 3. So there you go. That's an easy one there. This one here is a more advanced one. You should realize that if you put a table there and a table there, all right, so if I rewrite x plus 4 squared, you can take something off these two, a common table. So if you take the 2 off there, you have 4 there, and if you take a 2 off there, you have an x there, like so. And now you can see there's another table method in here, which is that table and that table. So I had to do a table method there first, and now I do another table method there. So what's common on each table? X plus 4. So I take one off of here and I take this off that table, and what's left is x plus 4 plus this 2. And then we can simplify this even more by having x plus 4 times by 4 plus 2 is 6, so x plus 6. There you go. Once again, this is a little bit tricky. What you should do is put your brackets around this like so. And then now we have a table and a table. So what's common on both tables? Well, it's x plus 3. And what's left? Well, we take everything off that table, so there's 1 left always. And we take one of these off here, so there's still, there's still 1 plus x plus 3. And then if we change this, then you have 3 plus 1 is 4, so x plus 4. All right. Now this is more a difference of squared, so it's something squared minus something squared. So if you realize that it's x, which is squared, and how do you get 16? Well, that would be 4 squared. So once you notice this pattern, you can put your two brackets. This x goes here and here. This 4 goes here, and then the plus minus. That's how you do a difference of squares. So I believe the rest of these are very similar difference of squares. So on your scratch paper, what you can do is go this, and if you look at 64, we know that it's 8 squared, and we know x, that gives us x squared, doesn't it? So we put our double brackets, 8, x, plus, minus. Okay. That's how we do this one. Okay. Remember here the x squared was first, but that doesn't matter here. The x squared can be second. That doesn't matter. So don't memorize the patterns. Understand you can do this. So this one here, we should see that there's a negative sign between them, and you have to ask, what can you square in here? So 36 is like 6 squared, and 49x squared. Well, if you square 7x, you get 49x squared. All right, so you have to know your indices rules for this. So now what I do is I put my double brackets. 6 goes there, 6 goes there. 7x goes here, 7x goes here, and then you have a plus and a minus, and then we're done. Next one. Again, we have a subtraction sign in two terms. So I ask myself, can I square something in 4a squared? Well, if you change this to 2a, that is the same thing as 4a squared. And if you change 25b squared, if you square root 25b squared, well, the square root of 25 is 5, and the square root of b squared is b. So now we have, once again, two brackets. We have 2a, 5b, 5b, and then plus, minus. The last one is a trick one because there's actually a table method before, so you should look for that, because I can actually take out a 2 from each one of them like so. And once I've done that, you should realize this x squared minus 4 is a difference of squares. So if I do this, I have 2, and then my difference of squares always has two brackets. And you ask, well, what can I square? X squared is like saying x, and 4, what squares get 4? Well, that's 2 and 2. And then we have plus, minus. and that's our final answer. So here's our video for factoring.